Welcome back to Nerding Out with Victor. Today, my guest is Liz Rice, who is a security geek and open source champion. I got to know Liz a number of years ago when we were both part of the early London Kubernetes scene. Since then, Liz has moved up in the world and written no less than 2 books, the most recent one about eBPF, which I actually got a copy of right here, thanks to Liz.
Amazing.
And today's conversation will be largely around eBPF, but not limited to eBPF. But without further ado, welcome to the show, Liz.
Thanks for having me, Victor. Good to be here.
It's always a pleasure catching up with you. So I guess we should start with eBPF. And so I guess a good question to frame that is, what's eBPF and why should I care?
Sure. So you might think, oh, it's eBPF. That sounds like an acronym. I want to know what it stands for. I can tell you it kind of used to stand for Extended Berkeley Packet Filter, but you can honestly forget that because it does so much more than packet filtering. What it lets you do is program the kernel. So we can change the way the kernel behaves dynamically. And the reason why that's so powerful is that the kernel is involved with pretty much anything interesting that we do with computers. So the kernel is really the bit of the operating system that interfaces with hardware. So if you want to write to a file or get a network message or something like that, then the kernel is involved. User space developers don't normally have to really think about it, but their programming languages are using these abstractions that call system calls that ask the kernel to do these things with hardware. The kernel's also looking after things like permissions and privileges and coordinating multiple different processes. So if we can change the way the kernel behaves, we can use that to influence all sorts of things in the system. Really common use cases would be instrumenting events in the kernel, to use that for observability, security, because we can affect whether or not things are allowed to happen or not. So we can do some really cool dynamic security tooling, and networking, where we can essentially take network packets and kind of do whatever we want with them, possibly passing them back to the kernel's networking stack or possibly doing something else. So tons of really cool kind of infrastructure level things that we can do with.
And if I'm not mistaken, the early days of eBPF's claim to fame really was Brendan Greggs at Netflix trying to debug fire hose of data, and traditional network diagnostics tools could just really not cope with the volume of traffic that Netflix had even back then. And that's where it really started. If that is correct assessment, or?
I mean, Brendan certainly was involved right from the early days and did some amazing work around using eBPF for that kind of observability, for tracing, for performance, measurements. Tons of really great work there. In fact, behind me, I've got the poster for the eBPF documentary. Little plug for that. Alexei, who's at the top of in the middle of that poster. Brendan is on there. He's if we're looking at the screen, he's to the left of Alexei. So that's Brendan Gregg. Alexei's in the middle, and he was at, what was Facebook back then, Meta now. And he had this kind of crazy idea to run programs in the kernel. One of the consequences of Meta being involved really early on is, again, things being done at massive scale. And every network packet that's been sent or received to Facebook or Instagram or whatever else since, I want to say 2016 from memory, has all been processed by.
Oh, wow.
Which is impressive.
That is pretty crazy. And so I think I first came across eBPF when there was, I believe, a Falco port into eBPF, and this must have been 5-6 years ago, probably, something like that. And that's when I started digging into eBPF and started playing a little bit with the tooling and got really interested in it. And then I've seen quite a few talks around that since. But you were, I believe you were at Aqua at the time, roughly, I believe, right? And is that was that your first exposure to eBPF around that time period, or when did you start diving into that?
So my first exposure to eBPF was seeing Thomas Graff, who I now work with at Isovalent, presenting on Cilium at a DockerCon, and it was, I want to say 2017, might have even been 2016. I think it was 2017. And I was doing a talk about how containers work, and Thomas was doing this talk in the same track about Cilium and how it was using eBPF to do container networking. And I remember thinking at the time, this is amazing. But back then you needed a version of the kernel that was, really cutting edge, that nobody actually...
None of the cloud vendors ran it.
Yeah. But I remember thinking at the time, this is going to be super interesting when people, don't need to build their own kernel to try it out. And so I'd kind of been keeping my eye on it. And then when I was at Aqua, one of my colleagues was talking about using eBPF. He was actually doing some kind of postgrad project using eBPF on Android, but he had the idea that perhaps we could use it for security purposes. And yeah, around the same time, I think Falco was doing its port from kernel modules to eBPF. They still support both versions. And then, so we built at Aqua a project called Tracy. And then I spoke at the eBPF Summit in 2020, which Isovalent organised. And I kind of realised through that event that although I felt like I knew something about eBPF, my tip of the iceberg, and there was this enormous sort of additional amount of information, and that all the experts in it, a lot of the experts, there was a ton of expertise in Isovalent. So that was the beginning of what has turned out to be a very fruitful conversation that we had back then about me getting involved with Isovalent.
Very nice. And so I guess it started as a diagnostics tool, but evolved into far more of a, I guess, programming language and run, I guess, a VM in a sense, I guess, from a programming perspective, right, to run. And talk to me a bit more about what you guys are doing right now at Isovalent with networking, routing, and all these things around. Because I mean, it started with diagnostics, relatively easy to wrap your head around, but now we're doing far more complicated things like building like networking and zero trust networking models around eBPF on top of eBPF, I guess. Like, walk me through how that actually works and how, well, basically the architect of how something can be accomplished using eBPF, really.
Yeah. So the other character I should maybe point out from the poster on the other side, on Alexei's right, is Daniel Borkman, who is at Isovalent. And he saw Alexei's idea about this kind of virtual machine in the kernel. He saw that being posted on a mailing list. And I think the way it was originally presented was maybe a little bit much for the kernel community to absorb. But Daniel kind of looked at it and thought, there's something really useful here. And he was involved in kernel networking. And he, I guess, saw the potential for using eBPF on the networking side. So he worked with Alexei, and they became the maintainers of the eBPF subsystem in the kernel at the time. And I guess what Daniel could see, his what he was able to anticipate was, we could intercept network packets and either manipulate them or drop them or redirect them in the kernel stack. So we can insert eBPF programs into a variety of different places in the networking stack and make decisions about what to do with the packets that we see. And for container networking, this is super interesting because of the way we create network namespaces for different containers. So you typically say you've got a container and running on a host. The host has a network namespace, and we typically put the container into its own network namespace. So if a packet comes, it arrives over a physical interface into the host, it gets traditionally routed all the way through the host's networking stack. And then there's a virtual Ethernet connection into the container's networking namespace, where it then goes through the whole networking stack again to get to the application. And what we're able to do with eBPF is intercept a packet early on and say, well, I can see this is intended for the container. So rather than going all the way through the host network, I'll just send it directly to the virtual Ethernet connection and make that a much shorter path.
So you replace entire IP tables, because I mean Docker container is basically a lot of black magic around IP tables essentially, right? Which is very fragile in many ways as well,
and can be a performance hit, particularly in a dynamic world like Kubernetes, where we're just creating and destroying IP addresses all the time. And those require IP tables to be rewritten. The way IP tables works, they have to be rewritten. The one change, the entire table has to be rewritten. So it doesn't scale very well. But we can bypass all that with Cilium.
Okay.
And then we also get the option to look at those packets and say, use it for network policy. So we can make decisions about dropping packets if they don't comply with the network policy. So right from the really early day, that initial demo that I saw Thomas doing back in 2017 was about network policies and the ability to drop packets and build these powerful network policies very easily.
Right. And I guess the two questions that comes to mind around Docker networking, what networking is in a Kubernetes or cloud native workload is, the first one is you kind of explained the physical routing to the container, but how would you do in a zero trust world like VM to VM routing? Is that something that's covered by the use case? Because that would be I guess how is that? How do you see that? I guess in the eBPF world, can you do host to host communication within that framework as well?
Yeah. So if we think about, you have to have a network connecting two machines, and we're not involved at the physical layer, but everything kind of above that we can be involved in. Cilium's vision is really to enable all networking, any workload to connect to any other workload without having to worry about whether it's in Kubernetes or on a legacy machine or where it is, from in a kind of naive way. They're just IP addresses. Now we might have to know how that IP address matches to a particular endpoint, but provided we know how to route to that IP address, why can we not? We can do that. But we can be quite sophisticated about knowing what all these different endpoints are, having network policies, understanding things at layer 7 as well. So we can be doing things like domain name based network policies, and API aware network policies. So for example, gRPC, policies that are able to interpret different gRPC requests, or HTTP requests. You only allow posts to this particular endpoint.
Right. So are you able to do, I guess, encryption as well when you do node to node communication in the eBPF layer? So you can actually do TLS directly in the eBPF layer?
Well, the way we typically do it is to leverage either WireGuard or IPsec. There's that old saying about don't roll your own crypto. So, but we can do that again very efficiently. The way I'm more familiar with WireGuard than I am with IPsec kind of implementation layer. And WireGuard presents itself as a virtual network interface, much like the way that containers present a virtual Ethernet interface. So from a Cilium perspective, we can configure these interfaces and send packets. We're making choices about where to send packets, which
Right.
to use, we use a WireGuard interface.
Right.
Yeah.
Okay. That makes a lot of sense. I mean, so one of the things that I got very excited about in the Kubernetes world in the early days, well, not so early days, but was Istio. And that is a project that had a lot of promise. Everybody was really excited about it, but it kind of fell flat. I know there are a lot of people who did implement it, but I haven't heard many success stories which didn't include a lot of engineers on page duty 24/7 to monitor it. Is that kind of the alternative to what you're looking at, or how do you see Istio fitting in together with this, or are they completely unrelated?
Yeah, so it is really interesting when we think about, what is a service mesh? And, if you ask two different people, you will get two different answers. What you want from a service mesh depends on, your requirements, your environment, and what have you. But really what service meshes are about is, let's make sure applications can speak to each other.
Yeah.
Maybe there's some load balancing involved. Maybe there's some, things like rolling out load balancing between different versions of a particular service. And I remember early on when I joined Isovalent, talking to Thomas, and he was saying, we already have like 80% of a service mesh, because, we already have encryption. We already have load balancing. Really, the only bit at that point we didn't have was ingress. And we now support ingress, and we now support gateway API. Kubernetes world as the kind of scalable big brother to ingress. And the advantage that we have in the Cilium world is that we're covering all the layers of the networking stack. So Istio has kind of had to build additional resources to represent these kind of concepts that are really networking based, that we can kind of handle within the networking stack. So when we think about, our vision of just being able to connect everything to everything, there's enough information in a gateway API definition to sort of tell us, well, okay, this request is supposed to be sent to this particular type of backend, and we already had Kubernetes services. We already had the ability to load balance across them. It's a relatively small lift to go from that to what people are calling a service mesh today. So yeah, I mean, when people say, okay, we're running Istio, how can we, can Cilium do this in a more lightweight way? The answer is yes. Do we reproduce all the Cilium resource types? No. All the Istio resource types? No, we don't. Do we use, I guess the other point about it is the way that we, the way that we can avoid using. So there's a new thing called ambient mesh coming into Istio, but let's just park that for a moment and talk about traditional Istio, where it uses sidecars in every pod. And there are a few sort of downsides to sidecars that apply, whether we're talking about service mesh or any other kind of instrumentation. You have to get the sidecar container into your pod, which basically means restarting the pod. So your instrumentation and your application lifecycle start being tightly coupled. You have to be confident that all the pods are actually instrumented correctly, that the container is being injected, whether that's in CI/CD or some kind of webhook. It's got to happen. Whereas if we can do everything at the eBPF layer, we only have to instrument the host. We don't have to instrument every single individual pod. So that saves us lots of resources. It means we don't have to modify running pods. We can just enable features in the kind of using eBPF in the kernel layer and in the Cilium agent, and it just works for existing running applications. The other cool thing is, if you have a proxy running inside the pod. So we use the same proxy. We use Envoy, which is the same proxy that Istio.
Yeah.
But instead of having one inside every single pod, we have one per host. In the sidecar model, every single packet has to traverse through the proxy and then out of the pod. Whereas not every packet necessarily needs to be terminated. If you've got a layer 3 packet or you've got a UDP, you don't necessarily need to have gone through a proxy. So we can avoid going to the proxy if it's not necessary. And if you imagine you have 2 pods on the same host, if they're communicating with each other, it's going through 2 proxies in the sidecar model because there's a sidecar in each pod. Whereas if we've just got one proxy on the host, we only have to go through the proxy once, if at all.
Yeah.
So the performance is really quite significantly improved.
How do you deal with, I guess, attestation and workload identity? Because that's 2 of the things that Istio does, right? Because that's the MTLS or zero trust element of Istio, right? If you're running a single, like one of the benefits, I guess, of running a sidecar is that you can tightly couple the identity with the workload. Whereas if you're running on the host, I guess you have less tight mapping, I guess. How are you thinking about that?
Yeah, so one point about MTLS is absolutely a lot of people have a requirement for all traffic to be encrypted, at rest and in flight. So we want to know that all connections are encrypted. MTLS is not the only hammer for the encryption now, right? We talked about WireGuard and IPsec earlier. So for a lot of use cases, if what you're looking for is encrypted traffic, you don't actually need MTLS from workload to workload.
Right.
You do want MTLS or something like it if you are actually wanting to cryptographically verify the identities at either end of that connection.
Right.
And if you do, then MTLS is one way of solving that problem. What we've done in Cilium is separate out the kind of handshake part that happens when you upgrade a TCP connection to a TLS connection. We've separated that from the encryption part. So what we actually do is have the agent at either end use a spiffy identity. So we're using spiffy Spire to get the cryptographic identity for each workload.
Right.
The agent actually does that handshake on behalf of the workloads. And if that handshake is successful, we then allow traffic to pass, and we can use WireGuard as the encryption mechanism. So the encryption and the identity verification are kind of separated out.
I see. But you still run some kind of PKI then within the cluster or within the workload as part of your agent, I guess server agent model, I guess.
Yeah. We built this with a kind of pluggable API for the identity mechanism. The kind of out of the box solution is Spiffy Spire, but it could be something else.
Right. You could plug into your cloud-based PKI if you wanted to, I presume, or
yeah. I mean, whether or not there's actually an implementation today against that API is,
Yeah. But at the end of the day, it's X509 at the end of the day, right? It's a standard.
Yeah.
Right. Cool. Let me take a step back and talk more about, I guess, security of eBPF, right? It is, obviously you mentioned already, there was a lot of reluctancy in accepting this into the kernel from early days for obvious reason, because now you can execute code from user space inside the kernel, which opens a Pandora's box of attack vectors, I guess. What have you seen around that? Obviously it must be a pretty reliable VM if it hasn't made it into the mainline kernel. There are a lot of paranoid people auditing that code before it makes it there. What do you make of that, and how do you see that world?
Yeah. So the important thing about eBPF is it goes through this process of verification before the program is allowed to be, or it's as the program is loaded into the kernel, it gets verified. And if it doesn't pass verification, the kernel rejects it.
Mm.
Now, what verification does is it ensures that memory access is safe. It ensures that programs will complete, that it can't crash. We're checking every single memory access to make sure there aren't any, null pointed dereferences and things like that. So that gives us some guarantees about the program being able to run successfully. Can't bring down. What we can't do with the verifier is tell the difference between a malicious eBPF program and a well-meaning eBPF program. So a really great example is dropping packets. I might want to drop network packets because I'm enforcing a network policy. Or if I'm a bad actor, I might want to drop network packets to mess with your traffic. And the verifier has no way of knowing what my intent was when I wrote a program to drop certain network. So this is where, the provenance of your eBPF program is super important. You need to trust your supplier of that program, that the thing you're running is going to be, well-intentioned.
Yeah.
So supply chain security and signing and all that kind of thing. Now you can absolutely do the kind of normal supply chain security around user space agents that typically come with an application. So say, for example, if you're running Cilium, you don't actually have to get involved in the nitty-gritty of loading and unloading eBPF programs into the kernel. There's user space agents to do that for you.
Right.
But if we're talking about a particular eBPF program and trying to have the kernel validate its provenance, you might think, well, can't you just sign the program? And the problem is you can't, because as you load the program into the kernel, it's actually getting adjusted by the user space loader to make sure that the bytecode in the kernel matches the data structure. Compile once, run every. So it means because you're actually adjusting the instructions as you kind of load them in, the program that you end up loading into the kernel is not the same as the kernel, as the program that you were delivered, you downloaded from wherever you downloaded it, or that you compiled. So you can't just sign, or you can't then have the kernel check a signature matches the like a hash of the instructions, because the instructions have changed.
Yeah.
So this is quite an interesting challenge for the eBPF kernel community at the moment, and there are a few proposals around. There's one I'm aware of where they're essentially validating that the user space agent that does the loading is signed and as expected, but having that verified from with.
Because it sounds like eBPF is the ultimate bad actor toolkit in the sense, right? Because you could essentially obfuscate or hide the content, or like a line in the shadows file or password file or even SSH config, and inject all kind of roadmap backdoors that you would never see from user space because it's intercepted and obfuscated, right? We even obfuscate, like I've heard of attacks where they like compromise like the ls command, for instance, that so it doesn't output what you expect it to output and actually hides files and whatnot. So like I guess it's an interesting attack vector that's kind of new for this.
Yeah. There's definitely, with great power comes great responsibility. There are tons of interesting new types of attack that you could build with eBPF. You can use eBPF to kind of monitor and observe eBPF.
Right.
So use eBPF to see what other eBPF programs are loaded, for example.
becomes very meta. Where you
yeah, it definitely. But you can also get into a bit of an arms race there, where you need the, if the attacker kind of gets in there first, they might be able to obfuscate themselves. It's it's kind of like you want to know that the kernel that you boot is the kernel that you intended to boot.
Right. Oh, we kind of got that with secure boot in a way, right? But now, I guess eBPF in a sense incompatible with secure boot because it kind of makes it void in a sense, I guess, because
yeah, I don't know whether there are, you want to be the first eBPF. Your eBPF monitoring code needs to be the first eBPF code loaded. So whether that's part of your boot, I think there's more work to be done in that area.
Yeah, and I think, there's probably a big opportunity for the Falcos of the world, right, to do IDS on the eBPF level and monitor all these bad actors. And I guess that brings me to an interesting question that I've been pondering as you call a lot on social media lately. It's the need for, I guess, antivirus in a traditional sense, more in the Linux world, that we've been blessed for not having to worry about for decades now. But given things that transpired in the last few weeks, we're starting to get to a point where, actually, maybe we do need to think about these things again, and maybe that is something to do with eBPF. What are you thinking about that?
So I feel like I need to mention the Cilium project called Tetragon, which is kind of like the next generation of Falco. So Tetragon actually instruments some lower level functions within the kernel. So Falco is instrumenting system calls. Tetragon is instrumenting sort of some well-known locations within the kernel. But so there are some reasons why that's actually more secure than the way that Falco does syscall attachment. But the real improvement is that Tetragon can filter events within the kernel. So Falco, the eBPF code is going to tell you, let's say you're looking for file open events. So it will report all of those file open events, and then in user space, filter out the ones that match the policy.
Right.
With Tetragon, it's actually pushing the policy into the kernel. So you do the filtering in kernel, you end up sending a much, 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 much reduced set of events to user space. And therefore you get incredibly low overhead. I think, if you're using Falco, with a significant set of policies, you will really know the overhead. I want to say that there was a benchmark that the Tetragon team did. I'm terrible at remembering numbers, but I'm pretty sure that the Falco implementation was some single digit percentage CPU, and the Tetragon equivalent was like 0.2.
Oh wow,
very.
That is a significant improvement. Yes. The other thing I wanted to cover was obviously the XZ vulnerability attack or supply chain security attack that happened. Well, we're recording this on April 5th. I don't know when this will go live, but this has transpired last, I guess, week now. And I was curious about the blog post that was on Isovalent's blog about detecting this vulnerability. And I was curious about the technical side of that, how you detect those vulnerabilities or that injection, I guess.
Yeah, so that's using Tetragon. I haven't looked at the blog post in enough detail to know exactly what events it's looking for, but I think it's a really, good example of how within really short space of time of that vulnerability being known, we were able to write a policy. It's just a policy. We didn't have to change Tetragon. We wrote a policy that detects and informs seeing that XZ.
Yeah, because it is something that I think, supply chain security, as you alluded to before, is a massive field that is evolving quickly, and I guess we're not quite ready for it, to be honest, in the open source world, because you start to see more and more of these state-sponsored attack vectors, attacks against the open source community and open source libraries maintained by a single guy, like the OpenSL attack springs to mind, where there are all like 3 people on the planet that actually understands its source code, and they're all working as volunteers on these projects. I mean, where's your head around this in terms of future of the industry, really, like supply chain security?
Yeah, I mean, as well as the sort of individuals who are involved, and the fact there are, how do you keep track of what each individual is doing? There's also just the sheer scale, the number of different possible dependencies that people have out there.
Yeah.
And I've been saying for a really long time now that I think runtime security is really the important part of this. So, I definitely believe in defense in depth. Don't get me wrong, the supply chain security stuff is incredibly important. Yeah. But what we really want to be able to do is detect malicious behavior or unexpected behavior at runtime, this whole kind of IDS idea. And I think if we contrast this with networking, everybody has run firewalls, enforcing network traffic drops for decades, I'm going to say. It's not a new thing to have a firewall that will enforce your network policy. In the runtime world, we seem to be, or in the kind of program execution world, there's a lot more hesitancy about this idea that, like, well, if we try to spot something doing something malicious, we might inadvertently also catch, expected behavior, and then we're going to get in the way of our programs, and we're going to cause more problems than we solve. And also the overhead concern about, if we're going to monitor everything that our programs are doing, is there going to be any CPU left to actually do anything? And I think this is where eBPF is proving to be incredibly powerful, and with implementations like Tetragon, because if we can find a way to express what's intended in a much better, we don't want, a lot of this has been done with like seccomp and trying to interpret this as a syscall layer, and who knows which syscall, if you're writing a web application, you have no idea which syscalls you're intending to call. But what you probably do know is things like whether you're expecting to talk to a database, and what domain names you're expecting to communicate with, and what files you're expecting to access.
Yeah, if you get a read on your password file from your Python library, there's probably a red flag there.
Exactly. Yeah. So if we can express those policies in ways that make sense to humans, that we can say, here's the set of files I'm happy to access, here's the set of domain names I'm happy to access, eventually not just tell me if we see activity outside of these bounds, actually just prevent it. Yeah. And again, that's something new that we can do with Tetragon in the eBPF world. Until now, we've had the ability to send an event to user space and say, I think this is malicious, and then have user space go, this is a malicious process, so I'm going to kill the process. But by that time, it's done asynchronously, so bad things could have already happened.
Right.
With Tetragon, we can intercept those, let's say it's a file open or a socket open. We don't like the look of it. It doesn't match policy. We can actually kill the process synchronously from within the kernel, so that syscall never gets a chance. And it's much more powerful. And yeah, if we can express the policies in a meaningful way, I think that's the future of security.
There's probably like a Pareto rule at play there as well, where you could probably block 80% of attacks with just a very small subset of blocks, really, right? Because there are some common behaviors, like your Go library on your web server or your app server is unlikely to need to open a socket or whatever it may be, right? For a backdoor or something like that, right? And I think,
and many attacks, if they're intended to exfiltrate data in any way, they're going to have to do some kind of network activity, or maybe they're going to have to write a file to somebody's thumb drive or something, but it's it's definitely
they need to get it out somehow.
Yeah, and it should be possible to write policies that contain what we expect to happen.
And I guess an argument for that approach is code obfuscation is becoming crazy good with AI these days, right? There are so many ways to obfuscate code today that you can't write a regex to fix this.
Yeah.
Right? It's near impossible because AI will think of ways to obfuscate things that nobody's ever thought about, and it can do it unique per payload for 1 million payloads, right?
Yeah.
But the underlying the way it needs to either read data or send or write data is essentially the same, right? So I would agree. I think that playbook probably is a lot more sound to catch a lot of issues rather than trying to do it on a more tailored basis, I guess. So I guess what you're saying, what you're thinking is IDS is the new antivirus for the Linux world, I guess, in eBPF's user space.
Yeah. Yeah. I mean, I don't know whether we'll continue using the terms like IDS and because whether or not that has the right, doesn't necessarily leave people with the right kind of sense of excitement and power that they need.
Yeah, I mean, it is funny that this comes up. I see at least a few times a year when we do at Skilling, when we do like security audits or security surveys for customers, and it's so often that it comes up like, "What's your antivirus vendor for your Linux servers?" And I was like, "I don't have one," but that's still. And I've heard this conversation from plenty of friends of mine who are like CTOs for companies that do sell to enterprise that they end up installing some like McAfee garbage on their service purely to make the buyers happy, not because it actually solves the problem, but because it's just the path of least resistance to get them off your back, get compliance off your back, right?
This is a problem with all sorts of things in the security world where there's a set of compliance checklists and people just want to know that you've ticked the box, whether or not that's
sensible,
meaningful or sensible thing. It's a bit like the password change rules. Everybody has known for years that you shouldn't ask humans to change their passwords because they'll just fall into a pattern that makes it easier to identify what their password is. And yet there are still, organizations out there that will require,
Microsoft.
Yeah. Really?
Yeah. I mean, it largely comes back to these compliance framework. Now we have a new NIST framework, which hopefully, I haven't read the new NIST one in depth, but hopefully that's gonna debunk some of the myths, particularly around password, because I think that password reset and the password strength, I think that derives from the first NIST standard, which is what, 15, 20 years old by now? Well, at least 10 years old.
I think you're right. I think that has been, certainly some of the compliance frameworks have wised up to that.
Yeah. Well, you would hope. Well, now even like SBOMs is part of the new, I believe, part of at least alluded to in the NIST 2 framework, I believe. So at least that's wising up a little bit there. And maybe that's something I have covered this in the past on previous episodes, but I'm curious about your view of the SBOM world, because that's everybody talks about SBOM these days, and it's the cool thing to talk about. But I'm curious, where's your head around that, and how do you see SBOMs kind of fixing supply chain security?
Yeah, I mean, it's a world that I'm less close to now in what I'm doing these days, but from what I can see, there's some good work being done. I suppose I do worry a little bit that we'll come up with all these amazing ways of enumerating every possible piece of software and doing all these. It's all about dependency management and vulnerability management. But all of that work will always take time. And if that distracts people from thinking about, but what about the runtime? Then I totally understand why supply chain security has had the attention it had. But the materials is an essential part of that thinking. But I do worry a little bit that we might be, I can't think of the there's a an idiom, a cliche about looking over here because
Right.
being distracted from the real.
Yeah,
over
I
there.
mean, if it's purely an exercise about collecting this for the sake of collecting it, then I completely agree with you that if it's not actionable, it's kind of pointless, I guess.
Yeah, and I think people worry about like false positives and just
Right.
being overwhelmed, and yeah,
Well, that's a massive one, right? In like, it's trivial to pull an SBOM from most software stacks today. It's pretty trivial to correlate that SBOM file with some CV database, and then you get a list of, oh, you're vulnerable to these 20 CVs. But in reality, you're probably not. You're probably vulnerable to like maybe one of them. If at like many
yeah,
of them are going to be false positives, right?
yeah. I think there's some interesting work. One of my ex-colleagues from Aqua has a startup called Backslash, where they're analyzing which of those vulnerabilities are actually reachable in
Mm.
your application. I'm sure there are other startups doing similar work. And then there's also the approach of, like Docker Slim having a smaller image so that
Yeah,
the smaller it is, the smaller the likelihood that you have that dependency, and reducing the number of CVEs that way. So there's definitely, interesting things that can be done there.
but yeah, it is currently, at least I haven't seen that tool, but currently it's very much a manual effort of like, oh, we actually are not using this function that's affected by the CV, so therefore it's kind of moot.
Yeah.
But path least resistant, you should just upgrade it and not have to worry about it, right?
Yeah. And I
Um,
guess over the last few years, we've seen a lot of auto remediation, press this button and
right.
GitHub will update the dependencies for you, that kind of thing. It's good.
Absolutely, absolutely. No, I think that's it's I don't think it's a good thing that we have more security oriented thinking, at least, and supply chain is actually making the rounds in popular press even today almost. The last thing I wanted to chat a bit about is compliance, because I know you guys obviously work a lot with regulated industries where you need to make sure that you are compliant. How do you find a bit of the dichotomy, I guess, that we spoke about before between checking all the boxes versus actually solving security? How have you found those when you're working with these real life customers, in particularly in financial services where they are heavily regulated and all that? Or how you find working in that world, I guess?
Yeah. Um, it is obviously a front of mind challenge for people in these regulated industries. How do I make my environment compliant?
Yeah.
Can I use Kubernetes? If I do this, will I still be compliant? So on and so forth. We didn't talk about this beforehand, but this is going to sound as though we talked about it, and I wanted to plug, because we, Isovalent and our friends at Control Plane,
Yes.
came together, and we've recently written a white paper about how you use Cilium in a Kubernetes environment to meet a lot of these compliance requirements around things like trust, to do in configuring policies. Yeah, it kind of uh, maps different requirements to some of those like NIST framework
Mm.
table of requirements. So there's some great work gone in there by my colleagues.
Yeah, Andy was actually the first guest on the show, so good
Okay.
full circle. Yes, we talk about a lot of these things, but not necessarily around regulated industry. But yeah, I just find it interesting when you deal with these regulated industries, because we get across a fair bit of them as well, and it's it's the old meets the new, because they want to be bleeding edge, but they are held back by a lot of these old methodologies, I guess, in a sense, and from these frameworks. But yeah, I'm looking forward to taking a look at the white paper. I'll probably chuck that into the description of the episode as well, if people want to nerd out about that. And I think we've covered a lot of good ground today. Is there anything else you want to cover? Anything you think we missed that's worthwhile for viewers to think about or be aware of, or other than plugging your book, of course?
Oh, there we go. Yeah, yeah, yeah. I guess the other thing that we didn't talk about is Cisco. Where,
Oh, yes.
yeah, at time of recording, Isovalent is, undergoing its acquisition. So it was announced before Christmas and hasn't closed yet, but hopefully very soon. And I guess quite a lot of people have been asking about, what does the acquisition mean for Cilium and for Isovalent customers and for Isovalent employees as well. And
Right.
so I'm really excited about it because basically the whole team is moving as one into Cisco in the security business group part of security business. And we get to carry on doing what we're doing. So we're going to carry on supporting Cilium. I know Cisco is super excited about, the open source work that we do, and really supportive about that. It's like we get to carry on being Isovalent, but we have the resources.
It's
Company.
It sounds like a good strategic fit for Cisco, and I guess that would mean quite a few more trips to Milpitas for you then, I guess.
Yeah, I guess I'll find out after close.
Yeah.
Yeah.
Excellent. Well, thank you so much for coming on the show, Liz. Very much appreciate it. It's been a lot of fun, and I have learned a lot more new things about eBPF, and I'm very much happy for that. So thank you much for coming on the show, and have a good one. Thank you so much.
Thank you very much for having me.
Cheers. Bye.